Hi guys, I hope you're good. I hope you're well and excited for our lesson today. We are working with equations today and we will be solving word problems. That's what we'll be looking at. And the word problems that we are working with, they are still linear equations, guys. So we'll be using like real life situations. We'll be using numbers. We'll be using money, different situations, okay? So please, 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 please be focused, bring all your attention to this lesson because you will enjoy it. All right, so guys, the first part of our lesson today looks into understanding what word problems are. So to solve word problems, we need to write a set of equations that represent the problem mathematically. So you will be given scenarios, guys, words, okay? And you need to ensure that you translate that language into a mathematical language. That's what we're doing here, actually. So also the solution of the equation is then the solution to the problem. So whatever solutions that you find in our equations will definitely be the solutions for whatever problem that we'll be dealing with at that time. So another thing, guys, that I need us to look at is also the problem solving strategies that we have, because we are dealing with word problems. So I need to give you a few guidelines that you will need to use in order to solve these problems, right? So the first part is read the whole question, guys. You need to understand, like you need to read the whole question. And secondly, what are we asked to solve for? That is very, very, very important, because you can't create an equation out of something that you are clueless about. So you need to have a clue of what are we actually trying to solve here, okay? And thirdly, assign a variable to the unknown quantity. So we need to assign a variable to whatever unknown quantity, for example, x. So we've always used x in mathematics. We've used x, we've used y, or any other variable that is out there, but you need to assign at least one variable. And also translate the words into algebraic expressions by rewriting the given information in terms of the variable. That is very, very, very important. As I've said to you earlier, what we're doing here is actually a translation of language. So you're moving from all of those words written in English there and writing them into the mathematical language, which can be an expression or can be also any equation. And set up an equation or system of equations to solve the variables. So that's another thing that you need to do. You need to set up a system, guys. You need to understand what you're asked for. If you're told that you are the sum of two things gives you a certain number, you know that you're adding the first variable and the second variable and equating it to that value. And also solve the equation algebraic using substitution. That is one important method that I need you guys to always remind yourselves of. If you don't get it properly now, go back to our previous lesson. We do have a lesson on substitution, and you will definitely get an idea of how to work with substitution. And that confidence, guys, is very important on this lesson, okay? So you need to use the method called substitution. And lastly, check the solution. So you need to try to verify if whatever that you've been working with is actually relevant to the question itself. Does it make sense? Like, does the solution that you managed to get make sense into the whole situation? So you need to always try to check your solution if you got your values correct. All right. So in front of you is one perfect example for word problems, and we need to solve this problem in a very, very special manner. So as the first rule says, read the question very, very, very well. So now let's try to read the question and see what are we really expected to do. So a shop sells bicycles and tricycles. So you have a shop that sells bicycles, let's say bicycles B and tricycles T. In total, there are 7 cycles, so the cycles include both bicycles and tricycles. And you have also 19 wheels. So you need to determine how many of each there are. If a bicycle has 2 wheels, so a bicycle, guys, has 2 wheels. So now you have 2B, so bicycle has 2 wheels and a tricycle has 3 wheels. So you have 3T there. And remember guys, the total number of wheels that you have is 19. So you already have one equation there. But now, as you can see, you have two unknown variables. You have t and b, and that means you need to find another equation somewhere there. So the first rule says read properly. Okay, so now let's see if we can't find the second equation. So the second equation, guys, you will be coming from this part, actually the first part. So it says there are in total there are 7 cycles. So it means the moment you add all your bicycles and also all your tricycles, so in total you have 7 of them. So guys, these are the two golden equations that we will be working with. So 2b plus 3t gives you 19, and also b plus t gives you 7. So we have b plus t giving us 7 because we have 7 cycles in total, and we've learned that the bicycle has 2 wheels and the tricycle has 3 wheels. So tricycle has 3 wheels. Just correct that. So tricycle has 3 wheels, so that's why it's 3t. So in total you had 19 wheels. So you need to equate the first equation, you need to label it equation 1, and the second equation you need to label it equation number 2. And because equation 1 does not have coefficients greater than 1 next to them, so we can make both either t or b the subject of the formula, but let's just make b. So we can say from equation 1, from the first equation that says b plus t equals to 7, we can now easily create another equation that says b equals to 7 minus t. That should be t there. So it's 7 minus t. So you've managed to create the third equation called equation number 3. So once you have equation number 3, guys, you can easily now substitute equation number 3 into equation number 2, because we created equation 3 from equation 1. So we can't substitute back into equation 1. So substitute that value into the equation that we never used. So the equation that we never used was equation 2. So we are going to substitute that value into equation 2. So this will be, I like writing equation 2 again so that you can see how we actually do this. So this is 2b plus 3t gives you 19. And it means in the space of b, I will substitute 7 minus t. So this will be 7 minus t plus 3t equals to 19. So solving this linear equation, let me just try to solve it up there. So this is 7 minus t. I'm just writing so that we have a clean space to work with. T equals to 19. So this becomes, as you distribute your 2 into those two values there, so this gives you 2 times 7 gives you 14 minus 2t, because 2 minus t gives you t, and we bring back that negative, and then we continue. This is plus 3t equals to 19. So grouping your like terms together, this would be minus 2t plus 3t gives you 19 minus 14, guys. And what is 2 minus 3? That gives you simply t, and 19 minus 14, that gives you 5. So you have 5 tricycles there. That's what you have, guys, 5 of them. But we are not done, because we need to find b also. How many bicycles do we actually have? So this is how we do it. We can now substitute t equals to 5 into any of the 3 equations now. So remember, equation 3 was created from equation 1. So it's the same thing. And you also have equation 2 there. However, I always suggest that use equation 3 because you already have b as the subject of the formula there. So you will simply just substitute t on the other side and just get your answer straightforward. So this is how you do it. So you substitute it into equation number 3. So if you substitute it into equation number 3, let me highlight equation number 3 for you. So this is equation 3, and let me just write it for you here. So equation 3 says b equals to 7 minus t, and we find that t equals to 5, so we need to say b is given by 7 minus 5. So that is why b is given, what is 7 minus 5? That is 7 minus 5 is going to be 2. So it means you had 2 bicycles and 5 tricycles. That is what you have, guys. And if you want to check your solution, you can look at equation 2 that tells you the number of wheels that you have, guys. So the number of wheels is 19. So if you substitute in, let me just write equation 2 for you. So you have 2b plus 3t equals to 19. So if you substitute 2, what is b? B is given by 2 plus t is 3. So that's going to be 3. What is the value of t? It's 5. Let's see if it's going to give us 19. So that is a 4 there, and that is a 15, and you get 19. So therefore your left hand side equates with the right hand side. So therefore you've managed to solve the problem that you were given. So you were given a word problem and you translated it into equations, and you managed to find or solve the problem that you had. So guys, this is how you deal with this kind of a problem. Okay, so without spending much time on this, I have one more example for you. So I suggest that you pause the video now, attempt this problem, and come back and let's see if you manage to do it right. Okay, so guys, worked example number 2 says Bongani and Jane are friends. So we can use B for Bongani and we can use J for Jane. And so we have 2 friends there, and Bongani takes Jane's maths test paper and he will not tell her what her mark is, and he knows that Jane dislikes word problems, so he decided to tease her. Bongani says, I have 2 marks more than you do. So that is the first part of the problem, guys. So we know at this point that Bongani has 2 marks more than Jane does. So whatever Jane got, we add that by 2. So whatever value that Jane got, we need to add it by 2. That is the first part that we know. And also it says, and the sum, so it means if you add, so the sum of both our marks is equal to 14. So the moment you add Jane's mark and also Bongani's mark, you need to get 14. So that is what we have from that statement, and just like that we have our 2 equations, guys. So it won't be that difficult to work with this one. So let's see how we can work around this one. So we know that Bongani's mark is given by J plus 2, so it's Jane mark plus 2, and if you add Bongani's mark and Jane's mark, you are going to get 14. So the first part, that is your equation 1, and the second part, that is your equation number 2. And guys, since B is already the subject of the formula here, we can easily substitute equation number 1 into equation number 2. The reason why we always create equation number 3 is because we're trying to make values the subject of the formula. And lucky for us, Bongani's mark, you just simply add what Jane got plus 2. So we already have B as the subject of the formula. So simply it's going to be, just say substitute equation number 1 into equation number 2. So this means you have, let's just write equation number 2. So this is J plus B, it must give you 14. And equation number 1 says on the space of B, you can just say J plus 2. So this is J plus B. Sorry, don't write B anymore. So we're just going to write this is J plus 2. So this is J plus 2 equals to 14. So if you add J and J, that gives you 2j equals to 14 minus 2, and this becomes 2j equals, what is 14 minus 2? That gives you 12. And if you divide by 2 both sides, therefore we know that Jane got 6. So we now know that Jane got 6, and we now need to use Jane's mark to find what Bongani's mark is. So we are going to say, since Jane got 6, and we know that if we add the two values together, we are going to get the other's mark, or we can easily say substitute J equals to 6 into equation number 1. So equation number says B equals to Jane's mark plus 2. So therefore, Bongani's mark is Jane's mark, which is 6 plus 2. So Bongani's mark, guys, is given by is 8. So that is Bongani's mark, guys. And to test equation number 2 also, which says Bongani's mark plus Jane's mark should be 14, and indeed if you add 8 plus 6, you definitely get 14. So that is how you solve this kind of a problem, guys, and it is not too difficult. If you struggle with them, guys, go back, revise, pause the videos, try to do them on your own, and come back and check the solution. So guys, thank you so much for joining me on this lesson, and I will see you on the next one.